This is 3.5. Look, when they mean dissociation, they mean when it separates. So it was like this. When it separates, it becomes H plus HSO3 minus. So this is the first dissociation. They're asking for the second. For my bad. So after the first one, you're left with this. Yeah, so you just split it up again. Gives you H plus SO3 minus. Look, for the dissociation, you can either have it like this with multiple equations and each time you just remove one H, or sometimes what they can do is you can just do it like the whole dissociation at once. So you have this, you could just go instantly 2H plus SO3 2 minus. But they're asking for the second one, that means you have to do it by order. So it's gonna be this one. This one you just have to memorize. The acid-base indicators, how you can tell during titration. Acid-base indicators, yeah, because depending on the color, you could tell if it's more acidic or more basic, and based on that, you can tell if it has more, like, relatively how much H plus there is. Acid-base indicator helps determine, yeah, because when the colors switch, that's how you know you're finished. It's not, you don't need to heat up anything. It's just it basically just looks like this. So you have the burette, whatever. You have the solution. You have the indicator in the flask. Let me draw the flask better. So conical flask or Erlenmeyer or whatever, and the base, and here's the acid. Usually you don't need to heat anything up. Find the number of moles of both. So here it's 0.4 times 1, because N equals CV. So this is V, this is C. We'll call them, for the NaOH it's 1. For the HCl we'll call it 2. So this is V2 and C2. And make sure it's either in decimeters cubed or liters. So you just divide by 1,000. So it's 0.4 times 1 equal to 0.4 molarity. Moles. 0.4 moles. And then here it's 0.2 times 2, which is equal to also 0.4 moles. So that means it's completely neutralized, so they're equal. And remember, the Kw at 25 degrees Celsius is 10 to the negative 14. So that means H plus, when it's completely neutral, so for example in like water, again look, NaOH plus HCl, this part will help a lot to experiment. HCl gives you salt, table salt, literal table salt, and water. So it's just salt water. So it's completely neutral. It's not acidic or basic. And remember, in water, they're equal. Also, another way you could tell is that the pH of water is 7. You should know this because 7 is directly in the middle. So that means that the concentration of H, remember I told you before, 10 to negative pH. It's another way you can tell. So yeah, they're equal, and they're both equal to this one. This is when you multiply them, or this is when you multiply them. So yeah, that's it. Okay, just find the number of moles. So again, same thing. So look, okay, suppose that 0.1 moles, so you have NaOH and it's solid, so there's no volume. So 0.1, 0.1, there's no volume, so it's because they're gonna ask about the molarity, so there's no volume, so you just take this one's volume. And the moles here, we have HCl, N equals CV. C is 2, 0. And V is 0.2. So again, like last time, you just do CV, so 0.2 times 2, you get 0.4. They're not asking how much it is, they're asking how many more moles. So if you do 0.400 minus 0.100, get 0.300. And then, okay, from the excess number of moles in the volume, calculate the concentration of excess. Look, it's kind of like, I don't really know how to, imagine they're cancelling out. Yeah, you're trying to neutralize it. So HCl plus NaOH gives H2O plus NaCl. You're trying to cancel them out. So it's kind of like negative and positive. Because let's say you have -1, -3, for example, and 1. There's gonna be -2 left. You're basically doing that. So you have 0.4 and 0.1. Cancel, you have 0.3 moles of HCl left. Yeah, after everything gets cancelled, you have of HCl left, or of H in general, there's 0.3 moles left. So you do 0.3 over 0.2, that's what you get. It's like it's 3 over 2. What is the concentration of OH? They give it here again. If you, for example, have one of them and you don't have the other, it's basic math. So OH minus is equal to Kw over concentration of H plus. They already give you Kw. So again, it's just 10 to the negative 14 over 1.5. Okay. So here, look. Student wants to find the concentration of hydrogen and hydroxide ions and 0.4 molarity acid, H2A, H2, this is important, at 298 or 25 degrees Celsius. Look. So H2A gives you 2H plus, I don't know, A2 minus, forget A, gives you 2H plus something, yeah? So what's the ratio is 1 to 2, not 1 to 1. Forget the subscript, yeah? Ignore this for now, we're looking at the coefficients. For every 1 H2A, you get 2 H pluses. So 1, 2, yeah? And you know this is 0.4. So if 1 gives you 2, 0.4 gives you X. Cross multiply. It's stoichiometry. 0.8 equals X. That's it. And then again, Kw is given to you. So it's just 10 to the negative 14 over 0.8. Because again, Kw, always remember this. H plus times OH minus. Okay. Students asked to find the pH of a solution in an experiment. He prepares aqueous solution of HCl by dissolving. Okay. you have HCl, and you dissolve 0.08 moles in 250 milliliters. So you have HCl, you dissolve it, H plus, Cl minus. You have 0.08 moles all over, because it's 1-to-1 ratio. Look, whenever it's 1-to-1 ratio, you can always tell. Like, not even without writing anything, you can always tell. It's you just have to find one of them. You find this, it's gonna be equal to this, it's gonna be equal to this. So we can find the moles of, you find the molarity of HCl, which is N C equals N over V. We have the N, we have the N and we have the V. Again, liters, make sure it's in liters. So 0.08 over 0.25. You get this. Always remember this formula, negative log 10 H plus. This gives you the pH. Okay? So you do negative log 10 and you put this, you're gonna get this answer. Okay. You guys should obviously know this, but I'm gonna use this color to make it more neutral. So the more the pH increases, so it goes from 0 to 14. The more it increases, the more basic. And the more it decreases, the more acidic. And right in the middle is 7, which is neutral. You have stuff like water, stuff like that, that's neutral. So look, when the pH increases, it becomes more basic, becomes more alkaline. When the pH decreases, it becomes more acidic. So look, here you have HCl. It's already an acid. When you add the base, remember the bases and the acids are on opposite side. That's why acidic basic, because base acid. So for example, here you have, let's say HCl is 2 pH. If you put a base that's like, let's say 14 pH, no matter the, like, see how the volume is smaller, either way it's gonna increase, even if it's by 2.1, 2.0, 2.01, you get like that. Here's the opposite. It's already a base, and here you're adding an acid. So when you add an acid, the pH is gonna decrease because it becomes more acidic. And then here, H2O, and it's just salt. Salt doesn't really have a, like, salt's pH, I'm not sure about it, but it doesn't really affect that much. Salt water. It's not, pH doesn't really change. Okay. Again, it's just, so for this one, do negative log 10 0.36. Okay, do negative log 10 0.36. It's on this side to make it show more. Negative log 10 0.36. Here you don't have H plus, but you have OH minus. You can find the other, you use one to find the other. Here already KW is given, that's good. So here look, NaOH dissolves into Na plus OH minus. Yeah, you guys already know this, you should know this. So then, listen, for acids you should expect the pH to be this low. That's how you know you're correct. Like, obviously you don't want the lowest number possible, but the lower it is for an acid, that means you're right. Because if, for example, let's say you get two answers for this, you get one really high, one really low, go for the really low one, because again, so look, so we know the concentration of, because it's a 1-to-1 ratio, concentration of OH is 0.62. So you go 10 to the negative 14 over 0.62. You get your answer, whatever it is. So again, because remember, KW equals OH minus times H plus. So then KW over OH minus gives you H plus. So then you do 10 to the negative 14 over 10 to the negative 14 over 0.62. You get the concentration of H plus, and then you just put it into the negative log 10. And then you get it. And then for the last one is the exact same. So you have, it's the exact same as the first one. So it's negative log 10 0.15. How's that it? I'm gonna be continuing 3.5 from last time because it lagged a lot. So here they're saying that 25 milliliters of HCl, and we don't know the concentration of it, is titrated. It was titrated by 0.025 molarity of NaOH. So here they're asking you to tell which one, and there's two ways to tell. One, that it's the one being titrated is the one down here. The other way is, look here, you see it's given the volume. Here you don't know the volume. Like, you can put as much as you want, but not all of it's gonna be used. The way you find out here with the burette, you're not putting in a volume, you're trying to find out the volume you used. Okay, the Erlenmeyer is this one, the conical flask. So they're asking if you put a few drops of methyl orange in this one, what color does the solution turn into? Not even in the Erlenmeyer, my bad. When a few drops of methyl orange are added to the solution placed, so whatever this one is, if you put methyl orange, what's it's gonna be red. You have to memorize that. And then for this one, for the last part, so there's write everything down that's given. So for example, you have the volume. Even if it seems like not important at first, you're gonna use it later. So I have 25 milliliters of HCl and 0.025 moles molarity of NaOH. Now here they give you the volume of NaOH. So look, here the volume of NaOH is given. So 18 milliliters. So look, if you write out the equation, it's gonna be HCl plus NaOH gives you, it's not important. If you check here, it's a 1-to-1 ratio. So however many moles this is gonna give, this is also gonna give, yeah? So look. So N of the acid equals to N of the base, or NaOH, and from now on after this I'm just gonna write like of the acid and the base because it takes too long to write it like that. HCl, yeah? Okay, so we know C equals to N over V. The way you can write this in terms of not in terms of N, what am I saying? If you cross multiply, you get N equals CV. What do we just say? That N of the acid is equal to N of the base. So that means C concentration times volume of the acid is equal to concentration times volume of the base. Yeah? So you already have, you're trying to find here the concentration of the acid. You have everything else you need except for that. So that means Ca is equal to Cb Vb over Va. So now just substitute everything. Ca equals unknown. Va is 25 milliliters, and you always want it in either liters or decimeters cubed. So 0.025 liters. Cb equals to 0.025 molarity, and Vb is given here, 80 milliliters, which is equal to 0.018 liters. So I'm just gonna remove everything. I just need space to write the equation, that's it, so wait. So CA, already said, equals to CBVB over VA. That means CA equals to, I already wrote everything down last time, so it's 0, the volume, the concentration of NaOH, 0.025 molarity, times 0.018 liters, yeah? Because it's in milliliters, it's in liters, all of it over 0.025 liters also. Put it on the calculator, or just look, these two cancel out, so it's 0.018, because yeah, look, so liters and molarity, yeah, cancel, you have molarity left and you have 0.08 left, 0.018 left. This question I got it wrong the first time, but you have to like really focus on what you're doing. So look here, I'm gonna write down the thing, BaOH2 plus, wait, okay, look, BaOH2 plus HCl gives you take the cation from here and the anion from there, so my bad, anion from here, cation from the base, so BaCl2 plus H2O. If you look here, it's not balanced, so you have 2Cl and only 1, so you add the 2 here, but now the number of H and the number of O's are unbalanced. So look, here you have 2 only, here you have 2 plus another 2 is 4, and the O, here you have 2, here you only have 1. So perfect way to balance is you just do this. But the main point that you need to understand is that a 1:2 ratio, yeah? So just remember that, it's at 1:2 ratio. So for every 1 this gives you 2. Remember that. So that means N of this one, N of the base, equals to 2 N of the acid. It's not like that, but when whatever 1 of this gives you 2 of this, that's all you need to know. So I'll write it over it right now, 1 and 2. So that means you can find here, just you can use the number of moles to your advantage now. So you have these two and you only have this. You're trying to find the concentration of BaOH2. You can find, you have the CBVB, CAVA, that one, you can use it here. So look, find the number of moles here and then you can use it. You don't even need the CBVB, whatever. So it's 0.075 molarity times 15 milliliters, 0.015 liters. It's 0.075, because remember N equals CV. So then if you do it, you get, do 0.075 times 0.015. You get a long decimal, but I'm just gonna write it down. 0.00, my bad, 0.00125. Okay, now think about it like this. If 1 gives you 2, then how much gives you the 0.00 whatever? Cross multiply. You get 2x equals 0.001125. Divide both of them by 2. So N of the base is equal to 0.005625. Wait, oh my bad. Okay. So it's 0.0005625 because we divided by 2. because if 1 gives you 2, then this is gonna be double this. It's not like I wrote it before that n of this is equal to 2 is the opposite, or whatever. Look, so this is the number of moles equals n, and n equals CV. You have the V, you're trying to find the C. So just replace everything. So that means 0.1235625 equals to C times 0.05. So that means C is equal to, not n, my bad, you don't use n equals CV, use the original equation, where n over V equals C. So we know this is n. So you do this over, the volume, which is 0.05 liters, you get C. So try it, divide by 0.05, you get 0.01125. Here they wanted in scientific notation. I don't know why it's like this. It should be, look, so 1, 2 should be 1.1 times 10 to the negative 2. Because they want two significant figures in scientific notation. It should be like that, 1.1 times 10 to the negative 2. But they accept it like this here, so it's fine. Okay, so the pH here is given. So this is where you use the 10 of H plus is equal to 10 negative pH. pH is given, and you're trying to find it, so you just do that. So you do 10 to negative 1.78, 10 to negative 1.78. Get your answer, 0.0165. It's a lot, but they wanted two significant figures, so just 0.017. OH, you do the KW over, so KW over H plus equals to OH minus, so 10 to negative 14 divided by 10 to negative 14 divided by this, you get this one. Now look, here they're asking for the concentration of H2SO4. Look, H2SO4 dissociates into 2H plus SO4 2 minus, yeah? That means 1 to 2 ratio. So whatever this is, so we have this. So if 1 gives you 2, X gives you 0.017. It's like last time. Cross multiply, get 2x equal to 0.017. Divide both sides by 2, you get the answer. Always read how they want the answer. I don't know why here they're asking scientific notation and they put it like that. Okay, look. This time is the opposite. They want the of CaOH, not of H. They want stuff of OH, my bad, not H. Or I mean, this one's of a base, the last one was of an acid. So you're gonna expect this one to be bigger than this one, obviously. So look, pH is this one. Again, it's the same thing, 10 to a negative pH. So 10 to a negative 13.78, you get the answer. Same thing, KW over whatever this is. So KW is 10 to a negative 14. 10 to a negative 14 over whatever this is. And you get it, yeah. So it's like that again. It's like the last one, exactly. It's the exact same as the last one. So because look, CaOH2 gives you 2OH minus plus Ca2 plus, 1 gives you 2, X gives you 0.6, 1 gives you 2, X gives you 0.6, cross multiply, 2X equals 0.6, divide both sides by 2. Okay, so here it's definitely harder than last time a bit. Or no, what is the exact same? Look, so HCl H plus Cl minus 1 to 1. Yeah, so that means if 1 to 1, so this is 0.2 and this is gonna be 0.2. So it's like that. And then you do Kw here is given, so you just do 10 to negative 14. Wait, I'm gonna write it here. 10 to negative 14 over the answer, and you just get it. خلاص. This quiz has a lot of repeat questions, but they're mostly easy. Okay, this one's this one's a bit hard. So okay, you have HCl and NaOH. We have so HCl is titrated by NaOH. So that means you have a flask. Oh, this flask is horrible. You have a flask and the burette, and here's NaOH and here's HCl. They give you all the information. So look here, you have for HCl, also it's a 1-to-1 ratio. Look, HCl plus NaOH gives you NaCl plus H2O, 1O, 2H, 2H, 1Na, 1Na, like that. It's 1-to-1. So that means N of the acid is equal to N of the base, which means Ca Va equals to Cb Vb. You're trying to find Cb right now. So that means you have the V and the C of the acid, you have the V of the base. It's given here. The endpoint is reached when 29 milliliters of the NaOH solution added to the acid. So here, look, always make sure it's in liters. So this becomes 0.05 and this becomes 0.029. So I'll rewrite. So that means that Cb is equal to CaVa over Vb. So Cb equals to Ca, which is 0.2, Va, which is 0.05, all of it over Vb, which is 0.029. Put it on the calculator, double check. 0.2 times 0.05 divided by 0.029. Yeah, you get 0.3448. It should be, if you look here, I don't know why it's not. See, this is another accepted answer if you round it up. Okay, all the other questions you're trying to find the concentration. This time it's different. This time you're trying to find the volume. So look, read it step by step. Ignore this part. Just because you see numbers doesn't mean automatically think of it. Read it step by step. So look, I'm gonna cancel out everything because it confused me first at first. Okay, so 0.5 grams of HCl is dissolved in water to form 250 milliliter solution. So that means the volume of the HCl is 250 milliliters. So now you have to find the concentration. They give you remember this one from last year. N equals M over M. Number of moles equals mass over molar mass. Small m over big M. So it's 0.5 over 36.5. You get 1 over 73. I'm not gonna write the decimal because it's really wrong, but it's okay. So now you have the number of moles for N, for HCl, and now now you have to find the concentration. So we know that C equals N over V. We already have N, we don't have V. We already have N and they gave us V. Now we're trying to find C. So C is equal to 1 over 73 divided by 0.25, or to make it easier, 1 over 4. Keep change flip. So 1 over 73 divided by 1 over 4 is 1 over 73 times 4 over 1. The concentration is, so I'm gonna write them here. So HCl C is equal to, in this specific, remember, so it's the question is split up into two parts. The first part is the HCl dissolving in water to give you the solution. So this is the concentration of the HCl. The second part here look, the second part is now what you have to, so now we know that the concentration of the HCl is 4 over 73. Because remember, it's split into two parts. So in the first part, we got the concentration. Second part is when they started mixing. So they mixed 100 milliliters of the concentration of the, mixed 100 milliliters of the 250 here, yeah? See why you need to read it part by part? So they used the 100 milliliters to do, use 100 milliliters of the HCl titrated by the NaOH. So the NaOH, they give us a concentration. And we don't have the volume of the NaOH, that's what we're trying to find. So look, HCl C is equal to 4 over 73, and the V here is equal to 100. In this, because again, it's split into two different equations. First equation is the HCl by itself, second one is both of them together, the HCl and the NaOH. V is 100, okay? For now, because we use the first part, forget, we use the first part to find the C. خلاص. So again, it's we just did the exact same compounds last time. It's 1-to-1 ratio. So that means 4 over 73. So CaVa equals to CbVb 4 over 73 times 0.1 equals 0.15 Vb. Now let's find out. So 4 over 73 times 0.1 divided by 0.15, you get 0.0. Okay, again, look, this is why you're gonna think it's wrong. Look, so Vb is equal to 0.365 liters. That's why you're gonna think it's wrong. Look, we got the answer in liters, they want it in milliliters. So, sorry, 0.0, my bad, 0.0365 liters, yeah? So, now they want it in milliliters, so you just times by 1,000. So, 1, 2, 3, answer is 36.5 milliliters. Always look at the units. Okay. Here, look, so a lot of these questions are just repeat. So H2SO4, see, now it's not a 1-to-1 ratio. As soon as you see like a subscript next to the H or the OH, you know it's not 1-to-1, so now you have to even it out. H2SO4 plus NaOH gives you Na2SO4 plus H2O, check, okay, there's two N's, so here you add a 2. I'm gonna use this color for all the additions. So here we added the 2, because there's two N's here. What else is missing? So there's 3 H's, no, there's 4 H's, see? So 4 and 2 plus 2. And here there's only 2. So if you add the 2 here, you get 4 plus 2 O's, that's 6 O's, and then 4 plus 2 O's, that's 6 O's. So again, it's a 1-to-2 ratio this time. For every one H2SO4 used, 2 NaOHs are used. So for every one of this, you get 2 of this. So now we find the number of moles now instead of using CaVa, because it's a bit confusing. You just find the number of moles, it's easier. So N equals Cv. So C here, this is C and this is V. I'll write A next to it, but you get. So that means it's 0.2 times 0.05 equals to 0.01. Yeah, so we'll write here n of a equals 0.01, and now you have to do stoichiometry. So if 1 gives you 2, 0.01 gives you x. Cross multiply, x is 0.02. So n of the base equals 0.02. Now use n over v equals c. N 0.02, v 0.015. So you do 0.02 divided by 0.015. 4 over 3, which is 1.3 repeating, and they wanted 3, so you just write 2 of the 3's.